A diode is an electrical device that will allow current to flow in only one direction. It's like a one-way valve. So here's our basic signal diode, small signal diode. We've got two connections to it. One is called the cathode and the other is called an anode. The cathode is denoted by this silver line. Now current will only flow from the anode to the cathode if we make the anode more positive. So if we put the positive voltage on the anode, current will flow through the diode. The diode will try to block any current that comes this way. This is the circuit symbol, so we can see the line there of the cathode, and that's the equivalent of the grey line there, and the arrow shows us the way that conventional current will flow. Three types of diodes we're going to look at. The first one is called the signal diode. Second one is a Zener diode, and a third is a power diode. Now this is the characteristic curve of a small signal diode. This is the voltage that we apply to the diode. So this is a forward voltage, making the anode positive, and this is a negative voltage, making the cathode positive. And this is the current that will flow through the diode. So what we're saying there is it's going to take up to about 0.3 volts before the diode starts to conduct. Once it starts to conduct, we'll get almost maximum current straight away. So in this case we're going up to just over 100 milliamps. In reverse, we apply the voltage, and as we would expect, because it's a one-way valve, no current flow until we reach a voltage, in this case 75 volts, where it breaks down. Now this destroys the diode and current can flow in the reverse bias. So this is what we call forward bias when the anode is positive, and this is called reverse bias. Current flows in forward bias after about 0.3, 0.4, 0.5 volts. In reverse, there will be a voltage where the diode breaks down, destroyed, and current will flow. The Zener is very similar to the normal diode in the forward bias. Here we can see we're saying it's taken about 0.5 volts to turn on. Once it's turned on, we get full current flowing through. In this case 10 milliamps, so it's a slightly lower current rating. The difference with a Zener is that in reverse there is a voltage that the manufacturer set where it will conduct in reverse. Now this doesn't break down the Zener. The Zener is made to work in this region, so it's made to conduct at 5.6, and we can get all different types of voltages for the Zeners. We can get 3 volts, 5.6, 6, 12, etc. So the manufacturer will set the voltage at which it will conduct in reverse, and we'll look at level 3 how we can use that to regulate supplies. The power diode has almost an identical curve shape to the normal signal diode. The only difference is that the voltages and the currents are much bigger. So this power diode can take up to 45 amps. It's also going to take a lot more voltage to break that down. So we could use this diode 750, 800, 900 volts in reverse, and it wouldn't break down. It would need up to about 1000 volts before it was destroyed, and we get that reverse current.